All right, welcome everybody for one of the side sessions that is happening or are happening at the same time right now. For an hour, we will tell you everything about the ref that there is to know right now. And with this presentation and this side session, we officially launch the latest version of the ref, which is the latest and greatest, of course, and you will see why. I'm here presenting, so my name is Birgit Hassler, I'm presenting on behalf of the Model Benchmarking Task Team, same as Ranjini, Swaminathan, who's over there. Then we have Jared Lewis, who is here for the REF delivery team, and then Monica Morrison, who is here for the RIF's CMIP Responsible Data Use Task Team. Come on in, have a seat, and let's get started. So what I will present today is different things that are related to the ref. You see here a list of the content. We have showcases. We will talk a little bit about the responsible use of the ref with dealing with uncertainties, observational uncertainties, and how to get ref ready. And we want to hear from you, and that will be there will be Q&As in between, but there will also be at the end time where you can actually tell us your ideas, what you think the ref could do as well. One little thing that I wanted to mention is we will be available the whole week. So all four of us that will present today will be here the whole week, but we will also have a ref booth, which is in room B2. And in all of the coffee breaks and the second half of the lunch break, we will be there to answer your questions and to hear about your ideas, what you have regarding the ref. So, CMIP7-ready ref. This is a slide that you probably, or the figure that you have probably seen today already. It represents the WCRP modeling multiverse, and we are, with the ref at the moment, focused on CMIP of all of those different modeling multiverse components. We have started thinking about the ref in the Model Benchmarking Task Team, where I'm a co-chair of. We have had the goal to better understand, or the task team has the goal to better understand past, present, and future climate changes in a multimodal context. And this is a prerequisite for reliable climate information from climate and Earth system models. And we want to understand the model capabilities and limitations. Essential to evaluate the model systematically and comprehensively with the best available observations and reanalysis data is one of the things that we really care about, and this is where we came into thinking about the ref. Especially, we wanted to see the full integration of a routine benchmarking and evaluation of the models into the CMIP publication workflow. There are technical challenges, there are scientific challenges, and all happened at the same time in trying to get the ref ready and to the point where we are now. And I will not be able to tell you all about these challenges in that 1 hour that we have, but you are most welcome to come and talk to me afterwards, or anybody. We can tell you a lot of different stories. So, where we come from, we learned from CMIP6 that metadata matters. The ref is an automatic framework that uses, that has on automatization that, kind of the data needs need to follow, or the data needs to follow specific rules for that automatization to happen. And for CMIP6, if you started caring about your metadata and your data, you're summarizing your data, that was great. But we found in CMIP6 that there were inconsistencies between modeling centers regarding some of the coordinates, for example, some metadata, some branching times. And these problems required significant effort by other modeling centers or package or evaluation package developers and downstream users to individually get the same fixes done over and over. So for a Simval tool, where I come from, for example, we have a number of models that had to have big or small fixes done, and individual fixes that we had were over 50. So like all of those specific models or specific simulations could not have run automatically. They needed to be fixed for whatever reason, and that makes an automatization difficult. The problems also with the fixes is that you have, individuals that implement fixes, and so the fixes might not, look exactly the same for each individual. If everything is standardized, it's easier to do the scientific analysis because you don't have to worry about the fixes and you don't have to spend time on the fixes. And the time that you have freed up through that can be spent on scientific analysis. So if you don't fix, you might get filtered out. That is the biggest problem, because fixing data simulations requires time, and a lot of people don't have that time, or try to avoid to put too much time into fixing all this. All that said is, you will see why I'm saying this, but this is basically a lesson that we have learned from CMIP6 in going forward with an idea of an automatization that would do the evaluation as soon as data would become available on ESGF. So our view, or our goal, our vision for the Rapid Evaluation Framework basically got started in May 2024 at a workshop that we had in Oberpfaffenhofen, and we were dreaming up something like a framework that would help a lot of scientists to look at CMIP data as soon as it comes in on, and it's uploaded onto ESGF, and so that you can actually evaluate and look at the data very, very quickly, and kind of decide from there on what you wanted to do with the data, what would be helpful, or where you think scientific analysis would be most beneficial. So we had the vision that we have a community-owned evaluation framework, not just like one specific package, but like a framework that can incorporate several different packages, that incorporates has an API and for metric execution metric generations, and is based on those community packages across, and it can be applied everywhere. So the REF is a complete end-to-end system providing a systematic and rapid performance assessment of the expected models participating in the CMIP assessment fast track. That's the goal of the REF in the version that we are showing you today. And it will be supporting, or we hope it will be supporting, the next IPCC assessment report cycle. It's a fully integrated evaluation tool that works on 2 nodes on ESGF, so that and there is a dashboard, a website available that will show you the results of that evaluation. So we have different diagnostic collections included in the REF. They have been decided upon after we came up in the model benchmarking task team with a lot of ideas what we would like to see. And then there was a community, so we asked the community, what do you think, what you want to see? And so that was kind of like an iterative process until we settled on 5 different themes that are, kind of like along the lines of the data request that came out. So we have oceans and sea ice, atmosphere, land and land ice, earth system, and impacts and adaptation. And then we have the different diagnostic collections available. A diagnostic collection is basically the big overview name that we gave, the idea that we wanted to look at. In the atmosphere, for example, it could be annual cycles or climatological maps or something, right? But a diagnostic could be, you look at different variables and, kind of like different ways. So you see that we will talk about the different diagnostic collections a little more in a bit. And each of those, or not each, but a lot of these diagnostic collections use observational data that are a key component of evaluating the model simulations. And from here on, I hand over to Jared, who will give you the nitty-gritty detail of the technical aspects.
Thank you, Birgit. So Here, this is a brief overview of the REF as a framework as a whole. So we take in pre-QA/QC data, and those data and observations end up triggering a new run of this framework. So what we do is we take those new data sets that are uploaded to each ESGF, we ingest them into our database. This database tracks all of the metadata that's associated with these files, from these local files. From that, and the collection of the different diagnostics that we have available, each of these diagnostics includes some requirements about what each diagnostic requires to run. And so it could be describing the variables and the grids that it requires in order to execute this. We form a large graph of all of the different jobs that are required, and then we execute each of these. Now, each of these executions may run on different providers under the hood, and this could be, some of them could be simple, but some of them could be quite big jobs. All of those results end up being collected together into these diagnostic collections, and we store all of the output associated with these executions. So as a file gets uploaded, we may trigger off in different runs depending on what that particular data set is. We store various outputs, so all of the log output, all of the NetCDF files, the figures, etc., and we grab some of that data out of those and put them in the database as well. So if you've got your laptop in front of you, you can go to this website here, dashboard.climateref.org, and this is kind of our landing page for our the REF itself. And so I'm going to run through here quickly, I guess, make this a little bit more concrete. We're going to go down the path about what happens to a given execution, and that hopefully makes this a little bit more clear. So if you go to the dashboard.climateref.org, you're going to be presented with this landing page. If you scroll down a little bit through the introduction, you're going to see some metadata here. This kind of shows the different groups that we've run and the most recent executed groups. This is a smaller subset than we've run at the moment. There's going to be more when we've launched the ESGF nodes. So so this is going to be particularly interesting as you see new data sets come in with CMIP7. If we go to the diagnostics area in the nav bar, we're presented with the diagnostic catalog. Each of these diagnostics is presented as a card here with various associated metadata. So what provider it was run with, how many executions were run, which reference data were used, for example. We can filter by which provider ran this particular diagnostic, which diagnostic collection it was a part of, and which theme that this particular diagnostic is part of. So let's take a look at ECS. It's probably a particularly interesting one. We can see when you go through to this diagnostic page, you've got, again, some overview about how many runs were successful, how we grouped each of the different executions that we run. We'll get to that in a second, as well as some information and some metadata and some documentation from the provider itself. If we go down a little bit, we're presented with the figures that have run across all of the executions in this particular, for this particular diagnostic, and we can filter these to look at a particular model that we're interested in. We can also present some scalar and some series values that we pull out of these particular executions. So here we're able to see little spark lines on the right-hand side of, in this case here, a global mean anomaly of risk and radiation versus TAS. So we were also able to drill down into the exact execution that ran that. We're also able to view the scalar values. So for ECS, we extract two different metrics, an ECS and a lambda value. This table is all filterable, so we're able to provide, for example, here, if we just wanted to look at the ECS value, we can filter down to just show that. These data here are also able to be sorted and downloaded. So we're able to download all of these values as a CSV if you wanted to do some analysis offline. We'll also touch on this a little bit in a later video. Now here we're showing all of the different execution groups that were a part of this run. So there was 100 and something odd runs that were a part of this diagnostic. Here we're grouping by different models and grids and variant labels. and each one of them generates a new run. Some of them passed, some of them failed. And so this is where the automatic metadata and being able to handle that in a consistent way really matters. If we drill down into a given execution, we can see the files that were produced for that one, as well as for each given execution. We may actually run this multiple times as new data sets come in. So here the data set hash has changed, so we make a new run. That could be through retractions, for example. We can also see which data sets we use in that given execution. So let's drill down into this task PI control data set, and we can see that, that it was used in various other ones. So we can see the files, as well as the downloading some of the netcdf files that were available in that given run. And then finally, we're able to look at the log output for that given run to diagnose anything that goes wrong. So first of all, before we round into some Q&A about that, what we've seen so far, Brini, is there any questions online?
Yes, the question was the illustration of the overview slide shows netcdf files. Are those netcdf files bias-corrected files?
It depends on the diagnostic that is being used. In this case here, we're using the raw data set input. So it probably depends on what exactly is in those netcdf files, on which diagnostic is being run, and which provider that is providing that.
Most of the time, I think they are not bias-corrected, because I think most of the diagnostics that we have implemented so far in the ref, they do not bias-correct the data. Are there any other questions? Please don't be shy. There are some microphones in the middle here, and then there are some microphones on the side with people that would be happy to bring the microphone to you. Yeah.
So with your work, are you bringing all the models to common resolution as a standard thing? Or?
No, so we're dealing with the models as they are. So we're not necessarily doing any pre-processing to regrid or anything. This is, can we take the CMIP data that we get from ESGF, process it, and run them through, for example, ESMValtal, and present those results?
If we intercompare directly to observations, then there needs to be some regridding done. That is diagnostic dependent if the model is brought onto the grid, or what grid was chosen, or if the observations are downgraded to the model grid, or the models were adjusted to the observational grid, and that's diagnostic dependent. But if you have that indirect comparison, then yes, it needs to be reformatted to a grid. Yeah.
In CMIP6, there was a lot of issues with a non-polar grid, and all over the shop different things, and if you wanted to regrid that to regular grid, was pain.
That will be done for you. That will be taken care of for you.
So in your ECS example that you drilled down into, only 37 of the 107 models were actually successful. What's the process when a model fails? Is there any alert that goes back to the modeling center to say, can you check why this isn't working, or is it left to the ref team to figure that all out?
So I will note that ECS is probably one of the harder examples to do in this case, because it requires stitching together multiple different experiments, for example. But we're working with a process for how we will manage that in the future. It will end up eventually circulating back either via an errata service or something like that if we find large systematic errors. We're not trying to spot fix all of the results. We're kind of letting them be as they are, and so it depends on whatever processes we come up with. This is also something that the steering group that's driving this will evaluate in future and come up with something that works.
Yeah, fantastic work, Jared and Birgit. This is super cool. First, great job. Second, I come here more as a forcings provider. So I'm curious, did you also have plans to try to do something similar for forcings?
So at the moment, we're focusing very much on CMIP6 assessment, CMIP7 assessment fast track. That is, again, the main goal of this. But the purpose of this framework is an extensible framework that we could apply to different problems. There's a steering committee, and we're going to figure out how we kind of manage that going forward. But the purpose of this was something, so it's an execution engine for different functions on different data sets. So.
Yeah, okay. Yeah, appreciate it. I mean, also asking here for the fast track, but I appreciate that this comes now, and the inputs should hopefully all be done. But okay, thanks.
Okay, we have one more question online. Is it possible to add diagnostics to the ref? I will come back to that, because that is probably a very interesting question for a lot of people. We have seen today earlier already that IPCC authors would be very, very keen on adding stuff to the ref, and I will talk about this in a bit. So Gavin, you're online. I will get back to that. So we have time for one more question.
Yeah. I really like the way that when you go to the website, it tells you what's just happened recently. Is there a way that you can sign up for if new data gets uploaded and there's new exciting results, can I please see them? Or is it something that it'll just be go to the website and check?
We're still open to new feature requests. That's probably not going to be in this, during this week. But this is an evolving thing. That it's also an open source piece of software. So if there's various requests for features, we can capture that and we can prioritize them and implement them as we see. So cool. I'm nothing against doing that. Thanks.
All right, Jared.
So now that we've seen how a given execution works, now we're going to look at a bit more of a overview, a cross-cutting diagnostic view. So we've got part of this, we have a data explorer as well. So data explorer in the top tab. Then we've broken this data explorer down to the themes that Birgit mentioned before. We also have a way of viewing some of the text that you'll see below, some of these descriptions as either a bit more technical or via a plain language approach. And so here we're going to drill down into the land and land ice theme. So we're presented here with the different assessment fast track diagnostic collections, the top one being soil carbon. We have a bit of an overview about what that means, as well as the reference data sets and a link through to the diagnostics that produce the figures below. And these are all dynamic figures that we're generating here across all of the different executions we make. We also have some JSON that describes these figures. So this is something that we can build on as part of the community if we have new ways of grouping and cutting this data in different ways. It's all the same data under the hood, but we can slice and dice it different ways. So here we're showing, for example, we're grouping by 2 different regions, and we can mouse over and see some values. We also are able to download these values directly as CSVs or link back to the table that we can see. We also point out which reference data we're using this. Not only do we have the scalar values here, we're also able to present series values. So here we're showing GPP annual cycles across the black line being the reference data. So we can mouse over the different lines and see about which one it was produced and the difference to the reference. We're also able to isolate given lines if we want to and show just that. All these data here are also able to be downloaded as you need. And you can click on the sidebar here to turn off and on different things. So this is like a first cut at some of these, how we show some of these values, how we actually show this graph in future may change with some feedback. Another type of graph that we have here are these Taylor diagrams, where we're merging together 2 different scalarimetric values for a given model in a chart. We also have various different, this kind of continues on for different diagnostics. Some of these have some red placeholder flags around them. That's where we're looking for some community input around what could be potentially described in that figure or what descriptions are needed. So before we continue on, I was just wondering if there's any follow-up questions about the Data Explorer itself.
So I was thinking that some of this data would be useful to just have some index that you compare against in a publication or something. But one thing I was wondering then is, what would be the recommendation for how to cite this if it's continuously updating? And is there any kind of like date referenced, and would that then give you some reproducible way to know what went into that?
So that was actually one of the key design criteria for this particular project. We track everything in a database, so we are able to roll backwards and forwards and provide results as of a different day, every given day. That's not yet implemented, but that is like where we're wanting to go. We're trying to make sure that we have this immutable record of all of these metric values that we calculated once. And so we saw those different executions. We could pinpoint one of those older executions if that was only what was available at that given day. As I mentioned, it's not necessarily there yet as a feature, but that is where we're wanting to go and how we've designed this thing. Thanks.
There will be also a slide further on exactly how we, kind of like we're looking forward, and I will come back to that, very similar question. Okay, we have a question online. The modeling centers are overwhelmed with the tight timeline this time. Are you going to cut any slack for files that need fixes? Who runs REF officially?
So these results here that are presented here were around biased climate resource, but we're working with various ESGF nodes, east and west, to be able to run this on their sites. So we've had some preliminary runs on ESGF, and those will be the official proper sets of results that are provided in the future. And so, yeah.
Yeah, maybe I should mention here as well. So there will be the REF, the dashboard that you see is something that will show the results that are calculated on 2 ESGF nodes, and that will be publicly available. So the idea is the data comes in, is uploaded to ESGF, and within a day you will have the results on that dashboard, or like as long as it takes. It triggers the new simulation, trigger the executions, and then the executions will be done as long as it will take, and then it will be on the dashboard. There is also always the possibility to run the REF in a containerized version, so you can download the framework and run it locally, and then you can actually do, run this whenever you want. But I will get back to that a little more in a bit as well.
Thank you very much for the presentation. Very, very very interesting work you do. In the beginning, I think Birgit said something about metadata. You rushed through all these websites. Can you please explain what kind of metadata you are storing, and if only versioning of the data sets and all these things?
So we're extracting all of the global attributes out of the files and storing them in this database that we use. And so those attributes in those files are then used to define which diagnostics we run. So if we, for example, cannot find the parent experiment for a given experiment, that result will be not shown in the portal. It won't ever run because we couldn't find the PI control run for a given experiment. So so I guess when we've tried to do this in the past, it's been difficult. If we find inconsistencies, it's hard to automate this. Previously, a lot of these figures would have been made by hand, and then you do get everything to pass, but that requires someone to manually align the 2 different files. So here we're relying very heavily on all of these global attributes. Now the new QA/QC process that's going to make this a lot better. But but the metadata, the attributes in these files are incredibly important downstream.
So I think, everything that's in the netCDF files will be stored for that specific variable, that specific model, that specific ensemble member. So those are the metadata that will be there. But what Jared was explaining is, like, the problems that we had for CMIP6, combining different data sets together that are needed for more elaborate diagnostics, where you not just use historical simulation, but something like a little more tricky, and then you have to decide on how to fix those things together. But that is also something that we have in the REF, and if that metadata doesn't fit, then we have a problem in actually showing it and analyzing it. All right, how much time do we have? Okay,
Okay.
You go.
Thanks a lot for the presentation. I have a couple of questions. One, so if I understood well, it's more a confirmation. So you're going to put all the fast track results through this system, okay? And the second one, is there a way to say if a model is not fit for purpose? So let's imagine you do an indicator. We do something similar on air quality in my institute. So if the model is not fit for purpose, you put a flag and things should be redone. So I was wondering if you have something similar. Thank you.
So we're not trying to make that determination whether something is fit for purpose or not. If a value is several orders of magnitude outside some value that we expect, we do have a little warning sign there to indicate that that is an outlier. Those results are still available for you to download if you want. So we're not doing necessarily the filtering. That is very much dependent on what you're looking at.
Okay, we have 2 more questions online. One more, sorry. Can you explain more about will run on ESGF? Do you mean it will run on ESGF index nodes and will pull in data from all other nodes?
So at the moment, the REF is, with the diagnostics we decided to use, all use monthly values. So the data volumes that we're talking about here aren't huge. And so we've had a commitment that the monthly files that are needed for this would be on the data nodes east and west that would be running these. I think we're not necessarily, it's not run as part of the index, it's run on the infrastructure that hosts some of these indexes. But yes, so it's a separate service. It doesn't, but it downloads the data from a local copy of it. But we're going to ensure that the files are needed both that are available in those nodes that we want to run them on.
Okay, we have one final question. If a group sees a problem with a calculation they think should have worked, how do we work out what went wrong and what needs to be fixed? Presumably you won't have time to work on each example.
That is correct. Yes, so there is the log output for every single execution that we run. And so especially for a lot of these tools, they produce a lot of output, and that should help you diagnose whether this is a problem with the REF and how we've actually merged things together, or it's a data issue. We have a GitHub repository, and feel free to make any issues for any things that you notice, and we can kind of triage them. We're trying to do things in a consistent and uniform way, so we're not trying to do individual fixes for individual models per se. But if it's a particular issue with how we're running this, we'd love to hear. So passing on now to Ranjini.
I'm just going to talk very briefly about just to give you an example of the science in terms of what diagnostics went into the REF. So Jared showed you several examples of some land surface variables where with the time series and the box plot or the spread, like the model spread. So this is an example of where we would like to be. So currently the REF has, we've decided to kind of like have one reference or observational data set per climate variable per diagnostic for every diagnostic that requires an observational data set. This doesn't mean we don't want to see more observational data sets. So there are 2 plots here that kind of illustrate this for 2 diagnostics that we have. The top one is the model spread showing the change in sea ice with respect to temperature. And so you see this for multiple generations of models. The current REF plans include doing this for CMIP6 and CMIP7, so that will be part of the functionality. So that kind of plot will be available. The bottom, you're seeing a time series of Antarctic and Arctic sea ice. And what you're seeing there are several observational data sets. So they're all in black with either bold or dashed and so on. So this is an illustration of where we want to go with the REF. So So what I'd like to kind of like convey here is that this is very much a community developed tool. So when the community came back with what diagnostic they wanted, we incorporated this. But in the future, there's nothing to stop people from adding different observations, kind of, to illustrate observational uncertainty or to see where models stand with regards to a multiple set of observations, kind of take it from there. So so the reference data set over here is also mentioned. So this is just to illustrate the process we went in terms of choosing the diagnostic, and all the time we've been taking feedback on what the community would like to see. So the GitHub repository is available for you to post your comments as well, so that this can be a living repository that grows based on community needs.
So one other thing, I guess when you're trying to come up with your figure that you want in your particular paper, often the figure that's shown on the Data Explorer may not necessarily map exactly to what you're trying to show. But the thing is that the data underlying all that figure is all available and able to be queried. So behind the scenes of all of this, we have an API. This API is able to be queried, and it enables us to do some really cool stuff. So first of all, I'm going to run you through something I can show about that. So here, first of all, we're landing on our Read the Docs page. This provides some information about how maybe if you wanted to run it locally, you could find some of that information under Getting Started. We also have some information around the different diagnostics and experiments and variables that were used as part of this, if you're interested in using your own data locally. But the one I'm looking at here is this using pre-computed results. So as I mentioned before, we have an API behind all of this, and then, this API also provides a schema that we can look at here. So this schema describes exactly what endpoints are available to be queried, and all the different things that can be queried as part of this. This is the same API that's used by the portal, for example. If we dive into one of those endpoints, we can see the different query parameters that were required, as well as the shape of the data that's returned. And so that's really useful because from that API, we can jump into this notebook here, which is the same as that one rendered there, and we're able to make an SDK using that particular schema. So now we've built a Python package automatically using that schema that we've had before. We're going to import some extra functionality, and we're going to instantiate this client and point it at this API that we've been talking about. We're then able to ask this API, hey, give me a diagnostic summary, and it returns this well-formatted, uniform set of results that can be used for your own analysis, for example. Here we can make a markdown file containing all of the diagnostics. We can also query for all the diagnostics, give me all of the metric values, so the individual scalar values in this case, for a given diagnostic, and that's an example of the shape of one of those. We can take those metric values and put them into a pandas data frame and make a quick portrait plot. You could do whatever filtering or aggregation you want on your side to make that figure how you want it, make it ready for publication. We're also able to do something similar instead of looking at scalar values, if we say for CI we want to grab all the series values, they look slightly different, and now they have, instead of a single value, they have an array of values. And we're able to also put this into a pandas data frame with all of the different metadata about those values and make this plot. So this is the same plot, a similar plot that Ranjini showed, and we could overlay our own observation data set that we want, or our own extra values that we have that we've generated offline and merge them together. We're also able to grab the different files that were provided as part of the ref. So here's all of the files that were generated for a given execution of the global warming level diagnostic. We're then able to pick out one of the NetCedia files and then figure out where it is. We're going to make it a bit easier to do this in future, but this is like the bare bones way of doing this. We're also able to then just load it straight into Xarray, and we get a Xarray data set. So no having to go to the website and download each of them independently. With this Xarray data set, we're then able to plot it and do whatever filtering or whatever combinational analysis we want to do. And this is all local, and this can be added to with whatever extra information that you have at your hands. So I would expect that this is a way that a lot of people interact with this particular set of data and be able to expand it to their own needs. Monica.
Okay, thank you. Oops.
Too far.
Sorry, now I really screwed it up. Okay. So one of the things that we've been working over on for the past 6 months, the joint task team between CMIP and Regional Information for Society, which is the Responsible Data Use Task Team, is to provide some high-level plain language guidance on what the rigorous and informed use of the Rapid Evaluation Framework looks like in its current form. And this is really just a document that provides some general guidance on the purposes of the REF, what its capabilities are, as well as what its limitations are, because the REF allows us to look into the empirical adequacy of our models, but that is it's a necessary but not a sufficient, right, criteria for our models to meet in order for them to be fit for various purposes. So this tries to kind of give you an idea of how you can engage in systematic comparison across models, which is one of the purposes of the REF. It gives you an idea of how the REF can be used as an entry point for selecting models for specific purposes, and that the REF is good for informing you about which models you might want to downscale or choose for various sorts of regional modeling exercises. But it explains that the REF is not some sort of model validation exercise, nor does it provide an account of model validation, and it's not really providing any sort of judgment of something like model goodness or badness in a universal ranking way. So you can go to this QR code to get the document. It's currently in its first version. You'll see that it has, as I said, plain language summary of what the REF is, some indication of best practices in there. There's also 10 considerations for thinking about using the REF in an informed manner, so thinking about how you want metrics that are fit for your purposes. You want to use multiple metrics. You want to account for things like observational uncertainty as well as model genealogy. And it also includes a checklist at the end so that you can see whether or not your use of the REF is consistent with what we take informed and responsible use to look like. And I will just say quickly that this is version 1 and we intend to iterate on it. So one of the things that we'd like is to have input from the community as to what you might want to see in terms of best practices provided in a more detailed manner. If you want guidance on how to use, if the REF ends up including CIDs, how to appropriately use those and interpret those from something like the REF, etc. So now I'm going to hand it off to Ranjini, who's going to talk a little bit more about how to handle uncertainty in the REF.
So one thing we didn't get too much time to touch upon is observational data sets. So they are a very integral part of the REF. So there were several considerations around the use of observational data sets and how to kind of process them and how best to use them with the REF. So for want of time, I'm not going to go into too many details, but please come talk to us if you have any questions around that, and we're happy to take Q&A afterwards as well. One thing that I wanted to highlight is that we've been through the process of REF development. We've been continuously engaged with observational data set providers. We've been participating in their meetings. We've invited them for community workshops. And based on their input, we've come up with an augmented list of observational uncertainties that can be facilitated in the REF. At this point, because the diagnostic development happened at a different pace from when we got the observational data sets ready and when this process was accomplished, the current set of REF diagnostics don't use these new observational uncertainties, but there is nothing stopping them from being used. And this is also an ongoing process. We're continuously engaged with observational data set providers. And for the future, we will be having consultations with modeling centers as well to see in terms of what they would like to expect from observational data sets in terms of uncertainty. So this is also going to be ongoing work. And you're welcome to come talk to us about any of this at any point.
All right, so if you now thought, hey, I'm a modeling center and I would really love to get involved in this, I'm going to tell you how you can do this and like what are the steps. First, we have created a list of QA or a quality checklist. The data or what we need from the simulations that are submitted to ESGF for the ref to be able to use these simulations. I can tell you already, it's not more or just a tad more. I think one more check that needs to pass than ESGF actually asks of the modeling centers anyway. So if you're following the guidelines on how to summarize your data correctly, you should be done. You should be golden. So please go ahead and do that, because we really would love to see your simulations in the ref showcased. So the more effort you put into that, the easier it will be to actually show the data. I was lying. That checklist is actually not online yet, but it will be by tomorrow. The CMIP IPO was a little busy with organizing a conference, so like this was not on the highest priority list. So there is as I had mentioned already, there's a containerized version available. So if you want to run your ref or your personal ref, or you want to check your simulations before you put them on ESGF, nothing hinders you. You can download your own version and let it run on your personal or your institutional cluster. And then if you have trouble installing it, there's always help available. You just open a GitHub issue and tell people, like the ref delivery team, they will be happy to help. And hopefully you get it running on your system so that you can actually look at your simulations before you submit them to ESGF. There is also, in case you wondered what kind of variables do we need to actually fulfill all those diagnostics that are available, that is all specified in the data request that we have submitted an opportunity for the ref to the data request. It's described in detail in the atmosphere paper, the data request atmosphere. But all the other papers from the data request link to that. So if you find it in any of those data request papers, it will link to the atmosphere paper. You will find all the variables and all the simulations that we would need to actually run those diagnostics. But there's also the Rapid Evaluation Framework paper, description paper submitted to GMD. Everything is in there as well. So you will find that the same information there as well. And the question that came up already, and I was very grateful that you asked, how do we cite the ref? For now, if you're writing a paper or a proposal, or you put like anything that the ref spits out into a presentation, that would be fantastic to actually, if you have those two citations up there. The first one is actually a Zenodo citation with the ref, the framework itself, or for the framework itself. The second is the paper that we just I just showed, is the description paper of the ref that is submitted to GMD. So those two things would be fantastic. I'm speaking German again. There is, so we have plans, and they are very concrete plans, on making sure that we put in provenance records, streamlined provenance records from all 3 or 4 provider packages into the ref, so that everybody who wants to use the results from the ref can actually use them also for IPCC. It's not implemented yet, but we are on the forefront on actually doing this and making sure that the complex citation, object citation, is fulfilled there. And we have expanded the ref, or there's plans on all different kinds of things going on. For example, like everything that you have seen so far is based on CMIP6 data, and you might wonder, hang on a minute, but CMIP7 is coming around, what is going on? Yes, we have thought about this, but we don't have CMIP7 simulations yet. But we have worked in downloading CMIP6 data and converting it in CMIP7 style data which means that we have included, branded variables, for example, to make sure that the ref framework can, or the framework can work with these simulations as soon as they come in. So that is already done. We're almost there. There's like most of the diagnostics actually work already with the CMIP7 style data. There's a few more things to do, but we're almost there. The ref is a community effort, and you will see later how much people have been involved in this endeavor so far. But we are very, very grateful for the organizations that have directly funded that work and those actions that happened. And a lot of people have given time and engagement, energy to build the ref. So we are very, very grateful that for that part. And it is already part of the community as far as we think, but it can be a lot more, and we get back to that. We have put a lot of effort in making the ref open source and expandable. So there is the expansion requires a community agreement on priority activities, coordination of the community efforts to deliver these, and dedicated resources. The community coordination governance will be provided by the ESMO core project. So the ref was born in the framework of CMIP, but it's bigger than that already. So it will be hosted with ESMO. There will be a new governing body that will be established that will defer to CMIP panel for any CMIP-related diagnostics or CMIP-related ref matters. The responsibilities of this panel will include approval of new diagnostics, reference data sets, and new packages. And there will be a call for applications for this governing body next quarter. So if you want to be involved in how to shape the future of the ref and what you want to get into the ref and how to prioritize things, please think about applying to become a member of this governing body. This is a community effort. It's not something that will be limited to only the delivery team institutions. It's far bigger than that already, and we would be very, very happy to have more people involved. So we have a bit of time to actually talk about expansions. And with that, I mean what you as the community can think of could go into the ref or should go into the ref. So we have time now for you to come up and pitch us your ideas. There's also a Slido available, and you can see the QR code at the bottom here that has 3 questions. Does the ref meet your expectations? What do you like about the ref? And do you have any concerns about the ref? Please go ahead and fill that out. The Slido will be available the whole week, so if you can't fill it out now, that's fine. But please fill it out. We are happy to hear from you, because this is supposed to be a community effort. So we want to hear from the community. But now, please come up and tell us your ideas. What do you think? What do you think should go into ref? What is missing? And where should it go?
Thank you very much. It's really exciting to see the ref launched. From my have expectation. So currently focusing on monthly diagnostic, but it matters for impact and responses is really extremes. Do you have a plan how to evaluate the extremes, such as extreme precipitation, extreme runoff? That really matters for the community. Thank you.
So there is I'm not sure. There is a runoff diagnostic in there. So there is a diagnostic about runoff already, but we have limited ourselves to monthly mean, data so far, just to make sure that we actually can deliver something on time. That means that doesn't mean that higher resolve data is not able to run through the ref. It is possible, but yeah. The sky's the limit. I mean, if you say that's your that's your diagnostic that you want to see, I'm happy to hear that, and we can talk about how we can make that happen. I should say that there will be the governing body that I was just talking about. They will ultimately decide on what will go into the official dashboard ref, the ref that is run on ESGF nodes. That has not just running it on those ESGF nodes has implications on the calculation time. So the time on the machine is provided by those nodes, and we don't want to overstretch our welcome. That doesn't mean that you can't use the ref for whatever you want to do. There's the containerized version. You can implement whatever you want in that. So you can, it's not available on the dashboard, but you would have a dashboard-like view, and you can implement any diagnostic that you ever wanted. That said, I can totally understand that you would want to see it publicly on the dashboard. So yes, you can pitch that idea to the governing body, and then we will see where it lands. Yeah, you're welcome. Go ahead. Don't be shy.
There's some online which Ranjini can do.
Yes.
Okay, just to break the ice as well. The one I would like to see maybe would be things related to stratospheric metrics as well. So some atmospheric chemistry, something like ozone, stratospheric. I know you're going to say, wow, if it can be runoff, these are going to be even more complicated. But like in terms of wish list,
yes.
And for the models that have interactive atmospheric chemistry, it would be great to see something about volcanoes, optical depth for for models that have SO2, and stratospheric ozone, at least Dobson unit recovery rates after 80s. That would be great to have.
I just actually did not want to say we can put everything in. I wanted to say there are a few ozone diagnostics in there already. So like total column ozone and three-dimensional kind of like climatologies is there. But yeah, so there is more. Absolutely, there can be more. And I hear you. Yeah. Yes, go ahead.
For regional and national applications, there might be a desire to bring in national and regional data sets for the observational kind of evaluation, and including other diagnostics and past trends and all kinds of other things. It sounds like some of that could be done in the containerized version. You drop out, you add in your own metrics and so on. Then I guess the question then emerges for people who work regionally is, does this replace all of our old analysis? Do we do it all in REF in the containerized version? Do we still need to drop out to do some? I think guidance on that would be really useful.
Yeah, well, thanks for that point. And we are happy to get input on what exactly what kind of guidance you would need. What we don't want to do is replace anything. I mean, the REF is supposed to help with a lot of things, but it's not supposed to replace a lot of things. So if we can help with kind of like streamlining the selection of models, for example, for downscaling, then that's fantastic, right? But we don't want to replace something like a framework that's already like working well and already there. But yes, please go ahead and give us some ideas on what we could do to provide.
Quickly, just off the top of my head, one metric that would be really useful would be model independence. Is that already in there?
No. Monica's laughing.
Sorry.
I have I see you, but like we have a question online.
So we have enough time to take the questions online and that last question, okay?
Shall I go? Okay. So the first question online is, if analysts should cite the REF papers, what about citing the upstream modeling papers? If this reduces citations and visibility, it could be problematic. I'll answer, and Birgit, you can step in. No, the idea is not that you not cite data. So you use data from the modeling centers, but you use the REF as a tool. So you should cite both, ideally. And there's no, there's no intention here that if once you cite the REF, then you don't have to cite the data, because the REF is just a tool that processes what comes in from different modeling centers. And in order for your paper to be complete in terms of like what data sets were used, you will have to cite those papers. So hopefully that clears up anyone's anxiety on not being cited. How can we provide feedback on units? Example, runoff is better expressed in millimeter per year or 1,000 kilometer cube per year rather than in obscure units of kilogram per meter square per second. Sure, yeah. So this also comes under a category of a broader range of questions that we got from IPCC authors about like how do I change this bit here in the ref, like what would I need to do and so on. Currently, so the way this will be done is through the diagnostic providers, because the ref basically just takes what the diagnostic providers give us and then it just runs it on different data sets. But we have raised this as an issue that the governing body should kind of come up with a solution with, because without going through a long process of like that would be needed for a new diagnostic, changes and adaptability is something that we would like for consideration. And I think Natasha mentioned that in her talk this morning as well. But we've got that noted down, and we'll tell you how in a... Yeah,
I think changing the unit is actually a lot easier than that. I'm looking at Jared and he's nodding, yeah. So changing the unit is not going to be a problem. We can do that like in the ref without adding it anywhere.
Yeah, but you'd need to know why and what and have the justification. So it's best
just
doing
for
this,
that millimeters per day.
So the reason we have processes is just so that everything is like, above board and rigorous.
We're running a little short on time, so I give Roland the last question.
Yeah, thanks. Thanks a lot for all the work you've done. So I'm a big fan of REF, and I had the same question as the data citation, but that's something that we can discuss offline. My question was more about the linkage between what is within the realm of the working group one, dealing with a system model, and what is going on with the emulators and all the scenario visualization tools. So is there a plan to have a way to merge those data, to compare them all together, to have, for example, a system model, global mean temperature for historical, and the result of CMIP? So do you have something in mind for the evolution of REF in the future? That might be of great use for the IPCC authors, and maybe the handshake between working group 1 and working group 3. Thanks.
Thanks for the question. I think it's a good idea. We can definitely, jump on that, and I'll get back to you about it. So I think we're gonna have to kind of carefully end this. I want to give big, huge thanks to quite a few people. First of all, the model benchmarking task team members who have come up with the idea, who have over and over and over been asked, provide this, provide that, do this, come on, give more information about this, so that the ref actually has some scientific background. And I'm extremely grateful that they were so accommodating. We have funders that have provided some money so that we actually could pay some of the people that from the ref delivery team and the packages. Huge thank to those guys, because they have done a tremendous job in about 1.5 years to get this sorted. Everybody, at the front, Jared, who has come up with like most of this and is like the brain behind like the whole framework. So thanks, Jared, for that. We have also, But that's not all. I mean, we have, there's one more person I wanted to mention that is not here today. So Forrest Hoffman, who is one of the model benchmarking task team co-leads, and also, kind of like working very hard on ESGF to make sure that everything is really well aligned so that REF actually can run on the ESGF node. So that's fantastic. And then a big thanks to you guys, because we have asked also the community for all kinds of input, for all kinds of questions, and all kinds of questionnaires. Please fill this out. Without you, it would not look like it looks right now. That said, there's always more to be done, so please go ahead, look at it, give us feedback. We will be available at our help desk in room B2. There is a poster at a post about 40 about the international approach to uncertainty. And there is stickers available. If you see somebody that has a REF champion, please come talk to them. They are most happy to answer any questions or just, kind of like talk with you about the REF. And yeah, with this, I hope you are as excited as we are that this is happening. This is the last launch that we are having of this thing. We have had a few launches before, but this is the last launch until we are CMIP7 ready. So welcome to CMIP7.